Good morning, grade 7. I hope you are all well. I miss you so much. Today, inshallah, we will start our videos by a small video to revise the Newton's law. We will start with Newton's first law of motion, and as I told you that Newton's first law of motion states that an object at rest remains at rest unless unbalanced force acts upon it. Okay, so if you put a pencil on a table, this pencil will not move from its place unless you give this pencil a force to move. Also, the object in motion remains in motion with the same speed or velocity and in the same direction unless you give it unbalanced force. If you shoot a soccer ball, this ball will continue in its motion in the same direction with the same speed unless it is experience any unbalanced force, like another player stop this ball or this ball stop by the most common unbalanced force that stop the or change the direction of the moving object. Who can tell me what is the most common unbalanced force that act on moving object? Yes, let's think. Yes, right. It is the force of friction. Force of friction. This is the most common unbalanced force that act on moving object. Okay, so if I ask you like this in this worksheet that will be downloaded inshallah on the site, and I ask you to enter this worksheet, if I ask you what state the Newton's first law of motion, yes, and please answer this worksheet and send it back to me on this mail or on Google Class, okay? So if I ask you to state the Newton first law of motion, what is the Newton first law of motion? Object at rest remains at rest. Object in motion remains in motion with the same speed and the same direction unless unbalanced force act on. Okay. By the way, the videos for Newton's law also will be uploaded on the site. Okay. So this is the Newton first law of motion. So I want you also to know that the Newton first law of motion is also called the law of inertia. So what is the meaning of inertia? Inertia, this is the tendency or the resistance of the body to change its position. Like when you are sitting on a lazy boy eating popcorn and watching a movie, and your mommy asked you to bring her a glass of water. Is it easy to move from your place? No, it's not easy. Why? Because there is inertia. What is inertia? Resistance of the body to change its position. Also, while you are playing football and you are moving right and left, forward and backward, and I ask you to stop immediately. Can you stop immediately at once? No, it's not easy at all because you want to change your position or your state of motion. So it's not easy at all. Okay, so inertia, this is the tendency, or it's more easy to define inertia as the resistance of the body to change its position. Okay. So this is very important. So if I ask you, Newton's first law of motion is also called the law of inertia, right, grade 7. Okay, so this is the inertia. So I want you to ask you something, please. If inertia increase, if mass increase, inertia increase, right? If mass decrease, inertia decrease, right? Because mass is directly proportional to inertia. For this reason, please, it's very important, okay, to wear seatbelt while you are driving a car or sitting beside your father or your mother while driving a car. Because if your father or mother stop immediately, okay, due to any cause, it's very important to wear a seatbelt to avoid collapsing with the front of the car or the glass. Okay, so please, this is inertia. So again, please, if I ask you what is the meaning of inertia, it is the resistance of the body to change its position. Inertia is directly proportional to mass. Yes, if mass increase, inertia increase. If mass decrease, inertia decrease. Right, grade 7. So this is Newton's first law. So second law of motion, please. And please, I want you to know the Newton's second law of motion. It's very important. Newton's second law of motion said that acceleration acceleration is affected by two factors. What are the two factors? The mass and the net force, right? So if I ask you, acceleration is directly proportional or inversely proportional to the net force? Yes, let's think. Yes, right. Acceleration is directly proportional to the net force. Okay, like in this picture, this is a grocery cart and this is a grocery cart. This cart, the woman is pushing with, for an example, 10 Newton, and this car the woman is pushing with 30 Newton. Do you think which car will move faster? Yes, right, this car, because the woman pushing it with 30 Newton. So as the force increase, acceleration increase. Okay, so what about the mass? What about the mass? Mass is, yes, right, inversely proportional with acceleration. As mass increase, acceleration decrease. As mass decrease, acceleration increase. Right, like also in this picture, in this grocery cart is empty, so the mass of this cart is low. This grocery cart is full, so the mass is high. So for sure, the acceleration of this car is higher than the acceleration of this car. Why? Because the mass is inversely proportional with the acceleration. So please, if I want you to write for me the equation of Newton's second law. What is the equation of Newton's second law? Equation of Newton's second law that acceleration equal force over mass. Okay, so we can simplify it by another way, that force equal mass times acceleration, like in this way. Okay, so if I ask you, like here in worksheet, state Newton's second law of motion. Yes, Newton's second law of motion states that acceleration is directly proportional to the net force applied to the object and inversely proportional to the mass of the object. Okay, it's very important, grade 7, to write for me while you are stating the Newton second law of motion, to set for me the equation that acceleration equal force divided by a mass. Okay, so or force equal mass times acceleration. So please let's revise a small point with each other, that mass unit is kilogram, right? Acceleration unit is meter per second square, right? So force unit is Newton, right? So 1 Newton equal 1 kilogram times 1 meter per second square. This is right? Yes, this is right. So if I ask you to define for me Newton, please define Newton. Yes, right. Newton, it is the force needed to move a mass of 1 kilogram at acceleration of 1 meter per second square. Okay, some of you ask me that we defined before Newton as the unit of force, right? But as in this lesson, we will define Newton as the force needed to move a mass of 1 kilogram at acceleration of 1 meter per second square. So if I ask you in this worksheet to, yes, I forget to put the definition of Newton, so okay, we can put it at as assignment in Google Classroom. Okay, so if I ask you to define, Newton, please define Newton. As I told you, Newton, this is the amount of force needed to move a mass of 1 kilogram at acceleration of 1 meter per second square. Okay, so this is very important. Okay, I want you to solve this, please. Yes, please solve this please by yourself, and we will solve it together. Zookeepers left a stretcher that holds a sedated lion. The total mass of lion and stretcher is 175 kilogram, and the lion upward acceleration is 0.657 meter per second square. What is the unbalanced force necessary to produce this acceleration of the lion and stretcher? Okay, so please, when you are going to solve this type of problems, please solve like this. First, get out the given. You have the given what? The mass. Mass is 175 kilogram and acceleration is 0.657 meter per second square, right? Okay, so, and he asks you to get the force. Okay, what is the force here, please? What is the force here, please? Okay, first, what we will do? Yes, right, as we know that. First, mark for equation. Yes, what is the equation here? Force equal mass times acceleration. Right, force equal mass times acceleration. This is the first mark for the equation. First mark for the equation, force equal mass times acceleration. Second mark for substitution with unit. Substitution with unit, grade 7, to avoid forgetting of unit, please. So here the mass equal 175 kilogram, yes, and acceleration 0.657 meter per second square. Right, so this is the substitution. This is the right substitution. Number with unit. So this is the second mark. Third mark for, yes, for the unit. The number is not so important. If you have a calculator, okay. If you don't have a calculator, number is not so important, but it's important to write the unit. Yes, here is Newton. Right. So some people will ask me, can I write here the unit kilogram meter per second square? Yes, it is right, because Newton equal 1 kilogram times 1 meter per second square, so it is right. Okay, this is Newton's second law. As you see, the acceleration is proportional. By the way, proportional like directly proportional. If you write for me directly proportional, it is right, and if you write proportional, it's right. Proportional to the net force of the object and inversely proportional to the object mass. So this is the acceleration, and this is the force. It is directly proportional, and this is the mass inversely proportional. Okay, this is the equation. Please, grade 7, for the next time, I told you, please, when I ask you to state Newton's second law, like here in the worksheet, please state Newton's second law with equation. Newton's second law with equation. Okay, thank you, grade 7. Okay, then this is the Newton's second law. Okay, what about Newton's third law of motion? Newton's third law of motion. Newton's third law of motion is talking about the force pair. What is the force pair? What is meaning by force pair? Force pair meaning action and reaction. Yes, right. Action and reaction. This is the force pair. Like here. You are shooting a ball and the ball give you a force. So you are shooting a ball with, you give action, and the ball give you a reaction. Okay, also when a ball is going to hit the earth, what happened? The ball hit the earth by the earth's gravity, and then the ball gravity is pushing upward again. Okay, so this is the action and reaction, and action and reaction is called force pair. So if I ask you to state Newton's third law of motion, Newton's third law of motion means force act in pairs. Force act in pair, action and reaction. And action and reaction are opposite in direction and equal in magnitude. Right. For an example, if I give an object a force of 20 Newton, the object will give me a force of 20 Newton but in opposite direction. The best example for action and reaction force or Newton's third law, while you are sitting on a chair. I'm sitting now on a chair. I exert a force on this chair, which is my weight. Okay, so this weight is exerted on the chair downward, and the chair exerts a force on me upward. My force equal the force that the chair exerts on me, but they are opposite in direction. I exert a force downward and the chair exerts a force upward. So they are opposite in direction, but they are equal in magnitude or equal in amount. This is 20 Newton, this is 20 Newton, but this is upward and this is downward. This is 30 Newton and this is 30 Newton, but this is left and this is right. So please, if I ask you, like here also in worksheet, state Newton's third law of motion. Can you state Newton's third law of motion? Yes, so easy. What is the Newton's third law of motion? All forces act in pairs. Or you can write it by another way, that for every action force there is an equal and opposite reaction force. Okay, يا ولاد, please, action and reaction are opposite in direction, okay, and equal in size. Okay, opposite in direction and equal in size. Okay, this force pair don't act on the same object. For an example, I exert a force in a chair and the chair exert a force on me. So when one object exert an action force on the second object exert a reaction force on the first object. Okay, so the object exert a action force on the second object and the second object exert a reaction force on the first object. This is the action and reaction force. By this we finish our small revision on the Newton laws of motion. Please, Newton laws of motion are very important. Please state Newton first law of motion, second law of motion, third law of motion. They are very important before going through momentum, inshallah, next video. Thank you and good luck.